Yes, Sasrika students. So today we will try to calculate the value of acceleration due to gravity. Everybody knows acceleration due to gravity is 9.81 meter per second square. It's very interesting regardless of the mass of the object, whether it's a small ball of half kg weight mass, whether it is a big stone of maybe 1 quintal or 1000 kg mass, or whatever the object is, whenever the objects fall on the surface of the earth, their acceleration due to gravity is same. This is another question we may take later on. Why, regardless of mass, the acceleration is same? Now, how we got this value of acceleration due to gravity? Acceleration due to gravity is basically the acceleration with which all the objects fall towards the center of the earth. So let us calculate this. According to second law of motion, F is equal to mass into acceleration. Let us say there is an object of mass m. We are applying force F on the object if it is accelerated by an acceleration of a. We say that the applied force F is equal to mass of the object into its acceleration a, according to Newton's second law of motion. According to universal law of gravitation, the force between two objects, let's say this is one object, let's say this is other object of mass m1 and mass m2, and distance between their centers, if it is d, then the force between them is equal to g into m1 into m2. We learnt yesterday the force between two objects placed anywhere in the universe is directly proportional to the product of their mass and inversely proportional to square of distance between them. This much Newton is the force, where G is universal gravitational constant. So this force is m into a, and this force is mg into m1 into m2 into d square, right? Students, when there is a free fall means whenever a body is falling towards the center of the earth, whenever a body is falling towards the center of the earth, this acceleration becomes acceleration due to gravity g. The acceleration is g. So the force acting on an object which we can say is placed on the surface of the earth, even if it is not falling, it's having mass m. Towards the center of the earth, there is a force given by the Newton's second law. This force is equal to its weight of this object having mass m. So that weight is equal to mg. In other words, we can say this is the force acting on the body by the earth towards its center. This is also a force g into m1 into m2 divided by d square. Now let us consider that again this same situation. This is earth, big earth having mass m, and again a small body placed on this having small mass chota m, small m. Now according to this law, universal law of gravitation, the force between these two objects will be equal to product of their masses. The mass of first object is m. The mass of second object, that is earth, is capital M, into g divided by distance between them. So this is, let's say, the center of the earth, and this is center of the body. So this distance now is r, radius of earth, plus the distance from the center of the earth, from distance from the surface of the earth till the center of the body. But this distance may be very small, maybe, you know, 10 centimeter or 15 centimeter if it is a ball. But the radius of earth is in thousands of kilometers. So we can neglect this distance and just imagine that the distance between center of the body and center of the earth is radius of the earth r. So F is gmm divided by r square. R is radius of the earth. M is mass of the earth. This chota m is mass of the ball which is placed on the surface of the earth. So students, these two forces are equal. Which force? F is equal to mg, which is given by second law. F is equal to g mb me r square, which is given by universal law of gravitation. Let's equate them. So we get m into g is equal to g m, capital M, mass of earth divided by square of radius of earth. M cancels with m. So we get a expression, acceleration due to gravity g is equal to g into mass of earth divided by radius of the earth square. It's a beautiful formula which can help us accurately to calculate the value of g. Let's put all the values. So acceleration due to gravity means the acceleration with which all the bodies fall towards the surface of the earth. This g is equal to, value of g is 6.67 into 10 raised to power minus 11 Newton meter square divided by kg square, right, into what is mass of earth. Now students, the mass of earth, we'll take a mass of earth, some approximate value is 6 into 10 raised to power 24 kg, right, divided by radius of the earth square. So radius of the earth is approximately 6.4 into 10 raised to power 6 meter, right? So now we are going to square this, and when we are going to square this, students, and then we solve this. So see here, this is 6.67 into 6 divided by 6.4 into 10 raised to power, see here, minus 11, 10 raised to power 24 plus 24 minus 6 to the 12, oh sorry, there will be one more 6.4 here, 6 to the 12 minus 12. So this will be equal to, now this thing we can calculate separately, and this is 10 raised to power 24, 12 plus 11 is minus 23, so this is 10, right? So this is 0.981. If you calculate this, so from here we get the value of g as 9.81 meter per second square. So 1 kg here will cancel with square, and other kg will cancel the kg which is inside this Newton. So ultimately, if you solve these units, you will get meter per second square. So this is how, students, the scientists arrived at the result of g, that is acceleration due to gravity. Okay. Having done this, now we're going to talk about equations of free fall. Equations of free fall. Students, we already have equations of motion. Can anyone tell me what are the three equations of motion? Patafat.
So
S is equal
first
to
is V
V
U
is
plus
equal to,
AT.
first equation,
U plus
U
AT.
plus A.
U plus,
U plus AT.
please speak loudly. Second, Amrit, S is equal
SC.
to
S is equal to U T
plus
plus half
AT
AD
square.
square.
And the last one, Sargun,
E square minus U square
V square
equal
minus
to 2AS.
equal to 2AS. Okay. Students, these are the equations, three equations of motion, beautiful equations of motion. They really help us to calculate final velocity, v, sometimes to calculate distance, sometimes to calculate time. But one thing is important. You remember when we derived these equations, we had one assumption. Anyone remember? In all these three equations, what is constant? Anyone? These three equations are valid whether for variable acceleration or for constant acceleration. Anyone?
Constant acceleration.
Correct. Remember students, these three equations are valid only for constant acceleration. Now, just now we understood that whenever any object, regardless of its mass, when the different objects fall towards the center of the earth, how much is their acceleration? Their acceleration, just now we have calculated the value 8.9.81 meter per second
Second square.
square. Now this is what? This is acceleration due to, this is the acceleration. This is the acceleration due to what? Due to the gravity of the earth, due to the attractive forces of the earth in its atmosphere. Whatever is there in its atmosphere and even beyond it, earth is attracting them. Am I right? So because it is acceleration caused by gravity, we call it acceleration due to gravity, g. And this is constant. This is also acceleration. This is constant. So these all equations can be written for free fall. What is free fall? Students, one is we are throwing an object. Okay, we apply a force. Now we are not applying any force on these three objects. Let's say there's a tall building or there's a mountain, there's a cliff. You can say this is a cliff, means tip of a mountain, very high. Let's say this is 1,000 meter high. Okay, so from this, if we drop one small ball, bigger ball, or a bigger ball, all the balls will fall down with how much acceleration? 9.81 meter per second square. This acceleration is known as acceleration due to, come on,
Gravity.
correct, acceleration
Gravity.
due to gravity. And you see that this value of acceleration is constant, and these three equations are also valid for constant acceleration. But these three equations are on horizontal surface or even vertical surface, whatever it is, horizontal surface where the acceleration is constant. Okay, so these three equations can be written for free fall also. Why? Simply because here also acceleration is constant, and in the free fall also acceleration is constant. That acceleration is acceleration due to gravity, g. So we will write these equations for free fall as, we will replace a with g. So what will be the first equation, students? V is equal to
U
u
Plus
U
plus
plus
G
G.
plus
dt.
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 T.
And second equation will be as distance
S is
covered
S
equal
is
to
will be ut plus half. Come on, students.
half
gt square.
into
G
c
gt
dt
square.
square.
square. And third one will be 2g
Gs
would be equal to v square
c
minus.
square minus u square.
So these are the three equations which are valid for free fall. All right, whenever you drop something without applying any force, you just hold it here and leave it. It will automatically go down with this acceleration. So these are the three equations for free fall. Now, based upon these equations, we will do some numericals. Okay, first numerical. Now, students, he says a car falls off a ledge. Let's say a small height is there. There's a car. Because of wrong driving, it falls down, drops to the ground in zero point 0.6 seconds. Okay, so this may be uh, some surface the car is not able to see, so it drops down the car, and it comes to the ground in how much time? 0.6